Okay, so moving on to question number 2. How do you calculate KSP from molar solubility? Okay, so KSP from molar solubility. Okay, so first I'll write out the definition of molar solubility. Okay, so molar solubility is the number of moles that dissolve per liter of solution. Okay, so I am going to write out an example on how one would calculate KSP when given molar solubility. Okay, so for example, let's say we had calcium fluoride. Given its molar solubility is equal to 2.14 times 10 to the negative 4 moles per liter. Okay, so step 1 on answering these questions is to write out the chemical equation for the substance dissociating. Okay, so in the case of calcium fluoride, I'll put it as a solid. And then I'll show it dissociating into its ions. So its ions would be calcium 2 plus and also 2 fluorine minus. Okay, so that is step 1. Step 2 is to write the KSP expression. Okay, so in this case, KSP is equal to the concentration of the calcium 2 plus multiplied by the concentration of the fluorine ions to the power of 2, since there is a coefficient of 2 in front of the fluorine in the balanced equation. Okay, so that brings us to step 3, which is just to insert the concentrations of each ion, so calcium and fluorine, and solve. So since there's a 1-to-1 molar ratio for calcium fluoride and the calcium ion, then we know that they will have the same concentration, which is 2.14 times 10 to the negative 4. In the case of fluorine, since there is a 1 to 2 molar ratio for calcium fluoride and the fluorine ion, I need to multiply the 2.14 times 10 to the negative 4 by 2. So 4.28 times 10 to the negative 4, and that is to the power of 2. And we get a final KSP value of 3.92 times 10 to the negative 4. So let me just add like a note here. Since the CaF2 ratio is 1 to 2. Okay, so let's see what our junior tutor said about this question. The solubility product constant KSP is the equilibrium constant for a solid substance dissolving in an aqueous solution. It represents the level at which a solute dissolves in a solution, and it is used to describe the saturated solutions of ionic compounds with relatively low solubility. Saturated solution is in a state of dynamic equilibrium between the dissolved, dissociated ionic compound and undissolved solids. For a general chemical equation, they have MXAY solid, and then they show that the subscript of M becomes its coefficient, and the charge that it has is the coefficient of the A. And then they show the same thing for the anion. The general equilibrium constant for such a process can be written as, and then they show the general expression for that. Concentration of M ion, concentration of A ion, and also X and Y are the coefficients of the ions in the chemical equation. On the other hand, molar solubility is the number of moles that can be dissolved per liter of the solution before the solution becomes saturated. Once a solution is saturated, any additional solute precipitates out of the solution. So, in a sense, molar solubility is the molarity of the saturated compound. Say, given the molar solubility of the compound, you can determine the concentration of the products after the dissolution of the compound using the balanced chemical equation. Then the concentration of the products will be used to calculate the solubility product constant of the compound. Okay, so this solution was correct. Very in-depth explanation. Okay.